thank you for being here at the very last session of Pycon AU 2024, before the very last session of Pycon AU 2024, which is actually the lightning talks, before the actual last session of 2024, which is the close. We have Mark Lakewood, who is a dad and software engineer. It's a software engineer?
Yeah.
Really?
Apparently.
Yeah, he lives in Perth, which is a really inconvenient time zone away from Melbourne.
Just been talking about it.
And he lives in he has lived in San Francisco, and he's worked in platforms for a company that sends lots of text messages and now works in getting the world through the energy transition as quickly as possible. And he is going to talk about turtles? Turtles, yes?
Turtles, yeah, basically.
Yeah, turtles. Yeah. Thank you.
No problems. Hi, everyone. Almost the last of the last talk, as mentioned. I'll try and make it quick. Good news is there's not a lot of code in here that you have to comprehend, being the last time of the day. Bad news is it's a pretty abstract talk. So hopefully the information gets in and you can just go away and think about it without having to think about it a lot right now. Cool. So, abstractions. First off, don't listen to me. So, every bit of advice that we get in the world should be in a specific context. And it's often more valid in one context and less valid in other contexts. The context that I generally work in are kind of early stage startups or fast moving bigger startups. That's a very specific context, although, you know, hopefully a big enough one for people in the audience here. And I think the important thing is there's a high rate of change, some would say chaos, and the speed to market is important. And when you're dealing with those, then hopefully these suggestions will help. The other thing that I would say is all models are wrong, and this talk is a model of a way to think about abstractions. Yes, as I said, it's very abstract, this talk. They all are wrong, but some can be useful, and even just some parts of it could be useful. So hopefully this will help you out. As the lovely chairperson said, I'm a dad for a 4 and a 7-year-old, been a software engineer for 16 years, mostly back-end infrastructure, services, that kind of stuff. Platform engineer and architect at Twilio. Sorry if you don't like the SMSs. We really try, but some customers are horrible. And a software engineer architect at Switched In, which is helping the energy transition go faster. So I did do some bad things, but I'm making amends for them. There's some other Switched In people in the audience. Ian over here, if you want to talk about the energy transition, come talk to him later on. If you want to talk about nuclear energy and why it might be useful in Australia, we're somewhere in Melbourne at like 8 o'clock tonight. Go and find us then. Cool, so what are we going to talk about? First off, what's an abstraction? The main meat of this talk is a model for thinking about abstractions. Yeah, I'm sorry for the abstractness. Then some examples and war stories, because who doesn't like war stories? And then hopefully some useful rules and guidelines for using abstractions. What you should get out of this talk is a way to think about the question, is this a good abstraction? Is this thing that I'm building or using the right tool for this job, and should I build it or should I find something else that does this for me? Cool, so what is an abstraction? I used to have a quote here. I used to have a couple of quotes here, but through multiple revisions of this talk, people went, quotes were stupid, so don't use them. So this is what I've ended up with. I think an abstraction is 3 things. I think it's a meaningful name, an interface, and most importantly, a mental model of the problem space you're defining, right? And a really good abstraction pulls all of these 3 things together and lets you think about the problem space that you're trying to solve. if you have one of these that is not quite right, then the abstraction kind of falls apart from being useful and becomes annoying and not great. But if they all work together, it's a beautiful thing. I think really importantly is like, why do we use abstractions and what do they do? And I think as we build abstractions, we have kind of design gravity, I like to call it. The bigger and more important abstractions in our design space cause forces to make our design distort, you know? And sometimes when you've got a really good abstraction, they accelerate your design and accelerate your software delivery really well, right? Other times you build that thing and you realize a little way in the future that it was a really bad idea and it's caused everything around it to distort because its gravity has pulled your decision making and your design space in a different way. And so getting our abstractions right and using the right ones can have a really large effect on the way that we build systems and most importantly, the way that we solve problems. And I will say the other thing is the superpower of software is the ability to change. Every piece of software that you build will change at some point. You should assume it's going to change and assume it's going to change sooner than you think it will. So when you build an abstraction, those abstractions that are hard to change nail your feet to the floor and means that you can't change as quickly as you want to, and you end up in a design space that you don't want to be. And you're neglecting the superpower of software. So I think there's like kind of a scale of abstractions, if you will. From the bottom left, kind of minor functions, up to the kind of top right core product, and you know how much we care about it. I reckon that the bottom, to give you an example, the bottom is like kind of like a minor function that gets some users from a service, right? Like it certainly has an interface. It's probably called get users or something, but it doesn't really matter. In the middle would be how we model policy and like users and identity and things in our application. You know, like whether we use a Django users model or write our own or rely on some other third-party kind of thing. And then kind of top right are often the core parts of your business, right? Like when we build a business or a project or whatever, we're solving a problem space. And part of solving that problem space is building these abstractions to solve the problem space. In this talk, we're going to talk about the middle stuff. The bottom left-hand corner, that's code organization. You're all reasonably competent. You can talk about that in a PR. Top right is more product market fit. I don't think this is a product manager product conference. I think this is a programming conference. So we're not going to talk about that. In the middle here is those abstractions I was talking about that we build and like set out our design space and how we're going to solve the problem. And those are the ones that have gravity that kind of distort what we're doing here. The other thing I'll say about design gravity is often we pile things on top of an abstraction and it kind of builds gravity and then they're harder to kind of pull apart. You know, the ones right in the middle here end up being what I like to call load-bearing abstractions. You know, they're really kind of foundational and then you kind of slap another thing on and slap another thing on and slap another thing on and then you're like, oh, moving and changing that is really, really difficult. So those ones in the middle we've got to get right or not do them, which is another option. So this is my model for abstractions. I think there's three types of abstractions. I think there's a type of abstractions where we explain something better, right? This is where you go, oh, I've got this problem space and like something clicks in your head and you kind of look at it sideways and you go, oh, but if I explained it like this and I built a thing that did it like this, oh, this is a beautiful thing, right? Like this is the holy grail of software engineering. The middle one is what I like call the sweep it under the carpet. It's where we get like a bunch of things and we're like, oh, this isn't nice. I don't like any of these things. You know what? If I just put it under the carpet here and I push it down, it's beautiful. I love it. Except that like there's a bit poking out here, and there's a bit poking out here, and when you step on it, it hurts your foot. But it is a carpet, and you know, maybe it will solve your problems for a while. And then the third one is the reuse abstraction, where we say we're going to do this thing over and over and over and over again, and we need to package it up in a way that we can do that over and over again, right? I think the important thing about this model is that often when we're building abstractions, we're not clear on why we're building an abstraction. And we kind of tend to mush all of these reasons into why we're building the abstraction. And I think the reason why I wrote this talk is that I had thoughts that were not clear about abstractions, and this was my way of like codifying the ways that I thought about abstractions. And it's really helped to kind of pull apart these different things so that you can focus on the trade-offs that we're making with these abstractions. As an architect, my canned answer to almost every question is it depends. And I think it's true with abstractions as well. So I'm gonna make some kind of pronouncements about certain of these abstractions. You may have already garnered some hints about my feelings about some of them, but it's always a trade-off, right? And so the main thing about this model is allowing you to think with clarity and decide which trade-offs you're allowed to make, or that you want to make. So let's start with explain it better. So this is really where you have that abstraction that enables you to see a problem with more clarity and explain it better to other people. I think there's a couple of examples like this. The two that I've got there are requests and Kubernetes, and I'll go into a bit of why I think request does a great job of this. These are big bets, right? When you decide to make one of these, it is a big bet because you're going to want to keep this around for a long time or a while, and you want to make it really good, right? I would also suggest that you should look around for ones that already exist because there are a lot out there. So let's have a quick look at requests. I'm hoping that everybody is relatively familiar with requests being a Python conference. Sorry, that wasn't particularly smooth, but I really needed a drink of water. So requests is an amazing piece of software. I love it. It's the best way to make HTTP requests. And thank you to all the maintainers and people that work on it. It's a great piece of software. And I think the reason why it's a great piece of software is, you know, HTTP exists as a mental model. And if you wanted to, you could open a socket, format some strings and throw it across a network. And you could get some strings back and you could pass those and do all of that stuff. You could do it all by hand. And that would be terrible, right? What request does really well is, you know, going back to that concept of what an abstraction is, it takes the mental model of HTTP about get methods and post methods and put methods and brings it together with an interface that is clear and concise and explains HTTP better. You know, it's not about the string formatting. It's about the fact that you want to make a GET request. And you want to put some data in that GET request. And you might want to put some headers on it. And all of that is really easy to do. It's very intuitive to do because it explains the mental model of a HTTP request better. And I think when you then look at like the Kubernetes ecosystem and their API system, I think Kubernetes is similar in that there's a little bit of a learning curve, But once you get the learning curve done, it really is intuitive about where the pieces fit and how they fit and where you should look for things, because it explains the container orchestration ecosystem that it models better or well, right? Better than a bunch of Linux processors and some file systems and stuff like that to make a container or however it's done under the hood. So that's the good. Sweep it under the carpet. Okay, so examples of this are kind of the bloated class, where you have a class that does a lot of different things, and like I really have empathy with this. I think we've all done it, right? And I think there's times to do it and times to avoid it, but it's where we've got a whole bunch of complexity that we just don't want to deal with, or we want to hide away so we don't have to deal with it. And I think there's ways to deal with this, but the most important thing is to kind of identify that you're doing it first, and then decide whether the trade-off is real. So the war story that I have is at Twilio, we built a whole bunch of platform tooling, like a lot of platform tooling. We were kind of early on in the Amazon lifecycle, the AWS lifecycle, so a lot of stuff didn't exist, and so we went out and built a whole bunch of stuff, right? We built APIs for everything, we built abstractions on it, did all of this amazing stuff, and it was a lot of fun. And then we kind of turned around and went, oh, that stuff exists now. And the problem with a lot of these abstractions is they were papering over things that already existed inside Amazon. They weren't very good paperings, and so the things kind of poked through and they didn't really work together very well. And then we did that thing I was talking about before where we piled stuff on top. And so they became load-bearing things that were really hard to like unpack and disassemble, right? And so those kind of abstractions lead you down a path that distorts your design space and the way that you can solve a problem. In our case, at some point we should have just gone, well, we'll just use like Terraform and all of the things that are out there. They weren't there when we started, but we should have been able to change quicker than we were. But because we built all these load-bearing abstractions, it became very difficult for us to back out of that problem. And so we wasted a lot of time backing out of that problem when we should have just been able to move. Third version of abstractions that I think that is really, really useful is the reuse abstraction. And this one is interesting because I think it is often what we're trying to do, and it's the easiest one to kind of sweep it under the carpet and slip into danger. And there's lots of really good reasons to do this one. This is where we're like, oh, we need to do this one like a bunch of times. Well, I'll just create some code that'll do it over and over again. And we don't really think about how we're going to do it or what the problem shape is or whatever. We just want to do the same thing over and over again. I will say about this one, the suggestions for how to kind of do this better is to keep the reuse very, very narrow. And have the bar for that, choosing to reuse things, create a reuse abstraction, very, very high. And if you do that, then you won't slip into the sweeping under the carpet and get stuck with an abstraction that is not useful to you and has not a great kind of return on investment. So, this is probably my canonical version of the sweep it under the carpet abstraction. I've done this. I've regretted it. I'm sure everybody's done it, and maybe you've regretted it, or maybe you haven't got to that point in your journey. But this is a really common response to, I have a server. I need to make HTTP requests to another server, so the server becomes the client. And I need to make a bunch of them. oh, you know what? I'm just going to make a class that wraps up all of the complexity and puts it over there, right? And there's some really good reasons for this that we think we have at the time. One is, well, they're all kind of doing the same thing. You know, we're all making requests over there, put it in a class. That's great. And I think this is the reason we make this choice is because in our kind of educational system, part of the programming kind of education system is we solve problems by building abstractions or interfaces or interactions. And so we get really wrapped up in building these abstractions and building blocks and stuff that we don't stop to think about whether we should build one at that point. I think a lot of the time when we do something like this, we're thinking about dryness, don't repeat yourself. And in this instance, I think the original sin, I guess, is this request method, the REQ method. And this is something that you can do in requests, and it's totally part of the public API and everything. And we basically say, like, well, we're going to put all of the networking code in this one method, and all of these different URLs here for get users and stuff, we'll just, have them as a brief wrapper around the actual request method. Because all requests to this server are the same. Has anybody built a HTTP server where every single URL behaved the same and every failure method was the same and the latency was the same and the methods are the same and the way you should react to errors are the same? Yeah, I haven't either. If you have, please come and tell me because you're some kind of like amazing engineer, maybe, or maybe something else is going on. So the problem here is that like we've tried to put everything together because we think it all looks the same, but it's not actually the same. We've tried to sweep all this complexity under the carpet, and it's not the same, right? In here, you would probably have like a I guess a raise for status? Yeah, because, we should just throw an exception for every type of return code, for every different type of method, also timeouts, latency, all of this kind of stuff. And so what you end up with is a class where you make changes to this one function and it ripples across your entire service because you decide to change one thing and it becomes, it causes some other problem, right? So how do we do this instead? Well, I would say use the abstraction that already exists. Request is an amazing library. Just use that. This little function here now moves down to the bottom left-hand corner of that thing instead of being up in the middle there. It's load-bearing, but much less load-bearing, right? You end up with a little function that uses requests, has all of the ability that you wanted before, and there's probably a get groups function over here that does something very similar to this, but it's actually not the same thing. Don't mix things that are not the same thing. And the great thing is that requests actually have this session object that allows you to compose in the common things that you want. Another big part I think that we miss with the sweeping under the carpet is we tend to try and encapsulate things in a black box class and push them away, when in actual fact what we should do is compose smaller pieces together to get the thing that we want. When I was doing this talk, a lot of people went, well, hang on a minute, what about generated, server-side generated clients? And I'm like, great point. That is not sweep it under the carpet, and it's not the same as the client that I mentioned before, because actually this client is the abstraction, and it is a reuse, and in my opinion, it's a reuse abstraction, not one of the other two. And as long as that client is really well scoped, it's a great version of the reuse abstraction. Keeping these scoped is the most important part of doing the reuse abstraction. And we see this all over the place. AWS, all the big cloud providers, they provide an API, a client that is auto-generated or however they do it, and that's the abstraction you should use. And once again, if the abstraction exists, just go and use that. Don't try and wrap it. Okay, so my rules for abstractions. Use ones that already exist, right? If you find yourself in a position that you feel like you need an abstraction, have a look around. The open source community does an amazing job of already providing these abstractions. A lot of the time, some of the time when we build things, we should have just used the open source one. Don't wrap them. Use them in all their glory. You get more power, more beauty from them, and you don't sweep things under the carpet, which causes leaky abstractions and all kinds of stuff. Make the bar for reuse really high, right? If you've done it once, great. You don't need to, don't complicate it. Twice, don't complicate it. 3 times, don't complicate it. It's just 3 times. Maybe 5 times, okay, we might need to reuse some stuff here. And optionality is a smell. Putting optionality in APIs, you're probably sweeping something at that point. And sometimes you've got to sweep. If you've got to sweep, make it composable, make it small. You might be able to sneak into reusable or explain it better. Cool, thank you.
Thank you. We've got a couple of minutes left over. Any questions? Now everyone's very much wanting to go and get a break before lightning. Yes, please, 1 sec.
So do you have some further suggestions on when we should use encapsulation, when we should use the composing?
Mm-hmm. Oh, sorry, I can just use this, right? Yeah, I should have done that sooner. At the risk of being absolute, probably don't use encapsulation. I've done a bunch of functional programming. Often encapsulation is not actually what you want. Or, more importantly, you don't want encapsulation in the big. You know, like make your encapsulation small and make those encapsulations composable with other things. And you'll get a lot more flexibility and a lot better, it's a lot easier to change things over time. Scoping these things are really important and trying to keep the scope really, really narrow and thinking of ways to keep the scope really, really narrow. And separate out doing things from working out what to do. Like that in itself means that you've got a lot of power about how the thing changes. Sorry, that was really abstract and probably not useful. You can come and talk to me afterwards and I can have a longer conversation if you want.
Yes, abstract and very on brand.
Yeah,
well done.
Sorry. Yeah, again.
One more question, if anyone has one. No? Great. Okay. On to the break and then lightning talks. And thank you again, Mark.
Yeah.